Welcome back to geometry. We are starting with 1-2. We're talking about linear measures. So we're going to do linear measure. A lot of you guys are probably going to be familiar with this because if you think about it, if you've ever constructed anything, if you've ever measured anything, you've done some measuring and some linear measuring. First off, we need to do some definitions. I know definitions, they're boring, but that is really kind of the key to all of geometry. So we're going to first off start with the definition of a line segment. Okay, what's the definition of a line segment? A line segment is a measurable part of a line that consists of 2 points. So, I'm going to say measurable part of a line. That consists of 2 endpoints. Okay. That is a line segment. So, a line segment. Going to draw a picture of a line segment. This is a line segment. The way we denote a line segment is the similar way we denote a line, except for without the arrows because it ends. A and B in this case, A, B are endpoints. So we do an AB. That is how you denote a line segment, okay? Line segments are measurable. That is a key. A line, so let's say we have a line AB. Yes, a line has points A and B. But the difference that separates a line, this is a line, and a line segment is the fact that a line segment has endpoints. I can't measure this line because it goes forever in both directions. Okay, so next, we need to talk about betweenness of points. So we're going to talk about betweenness. Betweenness. So, a point is between 2 other points if and only if. Okay, so we're going to write this for any 2 points. For any 2 points, A and B, another point C is between them, if and only if AC plus BC equals AB. Also, a note, all of these points have to be collinear. A, B, and C have to be collinear. I talked about what collinear was yesterday or in the last lecture, in lecture 1.1. They have to be collinear. This is important. If they're not collinear, then we have 3 points. What do 3 points make? A plane. That is not betweenness. Okay, I know that this definition seems really confusing. So imagine we have Okay, we have a line A, and here's point B. So we have this line. Point C is between them, so we're going to just put point C in here. If and only if AC, so that's this little section, plus BC, which is this little section, AC, plus BC, equals the entire thing, which is AB. You guys are probably familiar with this. This is very similar. You guys probably have seen this. Okay, next we're going to talk about congruent segments. Okay, so segments are congruent if they have the same measure. So, an example would be, let's draw. I'm going to switch up our letters. We're going to have P and Q, and we're going to put R right there. Let's say that this distance is 1.5 inches, and this distance is 1.5 inches. Is PR congruent? This is a sign for congruent. Is PR congruent with RQ? Yes, they have the same measure. Is 1.5 equal to 1.5 inches? Yes, you guys all know that. You guys all know that. 1.5 is equal to 1.5. So PR is congruent to RQ. Now, can I say that PR equals RQ? No. The reason is because these two are not equal. In order for them to be equal, they have to have the same points. So start and end. And that's not always true. Let's imagine if I put point P here and R here. And then let's say I have another R here and another Q here. Do these have the same endpoints? No, they're not equal. They are congruent. There is a difference. Congruent has the same measure. So, we are going to do some more examples. So, okay, so we are going to do an example of betweenness. This is an example of betweenness, okay? So we are going to have point J. We have a J here. We have a K here. And we have an L there. This is 8.4 inches. This is 3.4 inches. Okay, in order for it to be betweenness, remember JK plus KL, so this section plus this section has to equal the total, which is JL. Okay? So, what's JK? JK is 8.4. What's KL? 3.4. So what do we do? What do we get if we add these together? 4 plus 4 is 8. We put our decimal there. 8 plus 3 is 11. So it is 11.8. Okay? So that is if we are finding. So in this case, all we were trying to find was find JL. You do that by the betweenness theorem, okay? Let's do another example. Very similar example, just trying to get this in your guys' heads. P, and we have Q, and then we have R. Okay, so from here to here is 13 3/4. 13 3/4. And then P and Q is 6 5/8. 6 5/8. Okay, now we really need to use this betweenness theorem right here. So we need PQ plus QR to equal PR. Okay? What's PQ? Right here. PQ equals 6 5/8 plus QR. What's QR? We don't know. We're going to keep that as QR, okay? That equals what PR is. What's PR? That's the whole line. 13 3/4. 13 3/4. Okay, so how are we going to solve for this? You guys know how to solve for this. We take a minus 6 5/8. Subtract 6 5/8 on both sides. Fractions. I know you guys don't like fractions. So, we're going to do this over here. 13 3/4. How do we convert that to an improper? How do we convert this so that we can subtract 5/8? We need to get like bottom terms, like denominators. So we get 13. We need to multiply this by 2. Does multiplying it by 2, both on the top and bottom, change that fraction? No. The fractions are equal. It's just a simplified version. So we get 13 6/8 minus 6 5/8. Does that look like something that we can do now? Yes. So first off, we do our fractions. What's 6/8 minus 5/8? 1/8, right? 6 minus 5 is 1, and the denominator doesn't change. So we now have 1/8. What's 13 minus 6? 13 minus 6 is a handy dandy 7. Perfect. So what do we get? So this is our answer for this, okay? So QR is what we're left with on the left-hand side, and that equals 7 1/8. So this is our answer. The question would have been find QR. Just so you guys know. That's our answer. It's always nice to circle your answer. So this one, I would want JL equals 11.8. Circle it. I want you guys to show your work like this. This is for a reason. So, do you guys get this? The homework assignment is, if you guys want to start working on it, it is going to be a worksheet but some good ones to look over. So we have a worksheet due. Okay, but some problems that I would suggest working out if you're still kind of unsure with this. 11 through 19, odd. Guess what? You guys know odds are in the back of the book. This is on, trying to find the page. Let me find the page really fast. Okay. This is on pages 18 through 21. So pages 18 through 21. If you guys are looking for some practice problems to do, these are not due, but these are practice problems, 11 through 19. Also 21 through 33 odd. And then 34 through 38. And then the last one that I might suggest that you guys work on is 40 through 61. These are practice. It's a lot of just solving for the missing segment like we did in here. A lot of it solving for maybe the total. This is simple math that I'm sure you guys have done before. It's just a reminder, and we want to make sure that we have all of the basics done before we really jump into geometry. So thanks for watching.